Hello everyone, so I'm back again with one more video of AVL tree insertion. In the previous video lecture we have seen LL rotation, and today in this lecture we are going to understand the RR rotation. AVL tree, it's a self-balanced tree, and we can allow the balance vector 0, 1 and -1, but it other than that, any balance vector 2, -2, 3, -3, anything other than 0, 1 and -1, that is not allowed. Your tree gets imbalanced, and then they no longer be AVL tree, right? So let us take one example of our R rotation, right? So let us say, suppose I have 63, right? Here I have 54, and then 72 and 89, right? So I'm having this tree, the small tree, right? So first I need to find the balance factor. So if I find the balance factor, so for 89 it's a 0, 54 it's a 0, 72 it's a 0 minus 1, so -1. For 63 it's a 1 minus 2, so again -1, right? So now this is a balanced tree, so you can say it's your AVL tree, right? Now in an insertion, if I want to insert one more node, let us say insert 91, right? So if I want to insert a 91, so as you can see that it would be inserted to the right side of this 89, right? Why right side of the 89? Because it follows the constraints of a binary search tree, right? So we compare it with 63, 91 is greater than 63, right? And then 72, so 91 is again greater than 72, 89, so 91 is greater than 89 as well. So here this side we add 91. So once the 91 is added, this balance factor gets updated, right? So if I update this balance factor, right, so for 91 the balance factor is 0, for 54 the balance factor is 0, for 89 the balance factor is 0 minus 1, so it's -1. For 72 the balance factor is 0 minus 2, so it's -2, so it's a problem, right? And then for 63 the balance factor is 1 minus 3, so it's a -2, right? So here at the point at node 63 and at node 72, at both place it gets imbalanced, right? But as I told you that we need to find the critical node, right? So critical node, for finding the critical node we need to start from the leaf node, at what position it started getting imbalanced, right? So that is the 72. So this 72 is known as your critical node, right? So now you need to check that the newly added node, in this case it's a 91, right? So this newly added node is added at which side of 72? So as you can see that here it's right of right. You need to check the two levels from the critical node. So from the critical nodes it's a right of right, so it's a RR rotation. As I told you earlier also that which kind of rotation you need to rotate towards its opposite, right? So if it is a RR rotation, so you need to rotate your critical node, you need to rotate your critical node towards left, right? So left, in case here you need to rotate this 72 towards the left, right, towards this side. Again I tell you that it's like a chain. You just need to pull this 89 up, the 72 automatically comes down, right? So after that what you will have, 63, the left child of 63 would remain same, but the right child instead of 72, because 72 gets rotated, right? So now it's 89, right? 89 will be the right child. The right child of 89 will remain the same, that's 91, but the left child 72 gets down after rotation, so 72 will become the left child of 89. As you can see, you can check that it again the 72 is lesser than 89, right? 72 is greater than 63, so it follows the condition of binary search tree. And if you check the balance factor here, for 72 it's a 0, 91 it's a 0, 89 it's a 0, 54 it's a 0, and for 63 it's a 1 minus 2, so minus 1. So now it is balanced. So this is your AVL tree after rotation, right? So I hope you understood it, right? So let me take one more example, right, of this RR rotation, right? So suppose I have this 45, then 36, 63, 54 and 72, right? If you check the balance factor, so balance factor here for 72 it's a 0, 54 it's a 0, 63 it's a 0, 36 it's a 0, for 45 it's 1 minus 2, so it's a minus 1 over here, right? So right now it's balanced, right? But if I insert one more node, that is like 89, right? So if I insert 89, then 89 would be inserted here on the right side of your 72, right? So now the balance factor gets updated. So let me update that. So balance factor of 89 is 0. For 72 it's a minus 1, right? For 54 it's a 0. For 63 it's a 1 minus 2, so minus 1, no issue. 36 is a 0. 45 it's a 1 minus 3, so minus 2. Yes, now here is a problem, right? So this will become your critical node, right? So after the critical node, you need to check the two levels, right? At which side? So as you can see that here again it's a right of right. So it's a RR rotation, and you need to rotate your critical node towards left, right? So 45 is critical node, so you need to rotate it towards left, right? So now this 63 will become the root node. The right side of 63 will remain as it is, no change in that, right? Now on the left side, see, previously this 54 was the left child of 63, but as I rotate this 45 and in the other word, if I pull up, this will automatically comes down, right? So 45 will become the left child of your node 63, right? Now the left child of 45, that is 36, will remain as it is. But you might think that what about this 54, right? What to do with this 54? Because previously the 54 was left child of 63. So now it will become the right child of this 45, right? So here this is the place for 54, right? Now and this again you can check the condition for binary search tree, right? 36 is lesser than 45, 54 is greater than 45, 54 is lesser than 66 and 63, right? 72 is greater than 63 and 89 is greater than 63. So yes, it follows this condition, and then you need to check the balance factor. So for 36 is a 0, 54 it's a 0, 89 it's a 0, 72 0 minus 1 minus 1, 45 it's a 0, 63 2 minus 2 0. So now yes, it's a balance. So you can say this is your AVL tree, right? So yeah, I hope you understood this RR rotation. In previous video we have seen the LL rotation. Now in this video we have seen the RR rotation. This both rotations are single rotation, right? In insertion, during the insertion there are 4 types of rotation, right? Where 2 are the single rotation and 2 are the double rotation. RR and LL are single rotation, where RL and LR both are double rotation. So in the next video we'll see LR and RL rotation. Till then you just practice this RR and LL rotation, right? So I hope you understood it. Thank you for watching this video. Thank you.